So good afternoon, everyone. This is Audrey Russo, President and CEO of the Pittsburgh Technology Council. Welcome to Business as Usual. Joined here today with Jonathan Kirsting. He's Vice President of all things marketing and media. And we are thrilled to have our guest here today, who is Prith Banerjee from ANSYS, and I'll introduce him appropriately in a moment. But before we get started, I want to give a shout out to Huntington Bank, thank them for being with us along the journey. I think we are soon approaching the 6-month mark. So it's pretty insane that we have been doing this for this long and still finding a tremendously engaged audience, lots of people who are, joining us, talking about things. I think I heard that at least we've had about 4,000 plus people joining us, and plus the downloads and plus all the goodwill and relationships that we're building across the community. So thank you for that. Thank you for Huntington Bank. And so a little bit about today, because I mentioned that we have Prith with us from ANSYS, and he is the Chief Technology Officer. We have you on mute and we have a chat. So there's plenty of opportunity for you to engage with Prith. But first, I'm going to introduce Prith, and I'm going to say not only welcome, but I want Prith to talk a little bit about his background. Who is Prith the man, the CTO, and what the journey has been? So welcome, Prith. Thank you for joining us.
Thank you very much for inviting me, Audrey, and it's a pleasure to join you. So I've had sort of 3 phases in my career. I started my career in academia. I used to be a professor at University of Illinois, Urbana-Champaign. I was a department head at Northwestern. I was a dean of engineering at University of Illinois, Chicago. Did that for about 22 years. And during those years, did sort of phase 2 in my career, which was to be involved with a few startups, which is very relevant to this Pittsburgh Tech Council. So I did Excel Chip and Banner Chip while I was at Northwestern and Illinois. Again, took sabbatical, took leave from the university and did those 2 startups. The first company was bought by Xilinx, second by Quickstream Media. And the third phase of my career, which is where I am today, is to be part of large companies and heading up large R&D organizations. The first one was I was head of HP Labs worldwide for about 5 years. It was an incredible journey. And then I was CTO at 2 large industrial companies, ABB, a power and automation company in Switzerland, and Schneider Electric, another power and automation company based in France. And about 2 years ago, I joined ANSYS, and my current role is to look at the long-term technology strategy for ANSYS, which is a simulation company. But I have been very fortunate to have worked in academia, in startups, and in large companies, and hopefully able to leverage all my experiences in my work that I do today.
It's great. So great for you to be here with us. And so as we look at, how companies have responded to COVID, a few of them have actually been called into action before others, especially those like ANSYS who have global operations in China. And it wasn't in Wuhan, but I know it was in another city in China. Many years ago, Brian Kennedy and myself actually visited ANSYS, and I think it was in Singapore, if I remember correctly. So can you talk about the early days of COVID and your operations in China? Talk about how that set the stage for how you operated with your employees and your customers.
Absolutely. So first of all, just a little bit of introduction to ANSYS. ANSYS is an engineering simulation company, right? We help our companies design and develop the most amazing products, from sort of what we call computer chips to rocket ships. So the core technologies, using our technology, companies use they build their products completely in the digital domain, right, on a computer. And so we use our software to solve what are called partial differential equations using finite element, finite volume methods, right? So this is software methods used to simulate the physics of the world around us. And the physics can be fluids physics or mechanical fluids or electromagnetics and so on. This is what we do. And we are a company of about 4,000 employees, about $1.5 billion in revenue. We are truly global. We have locations in more than 80 countries around the world. And as you said, we have a fairly big operation in China. So when COVID hit, I mean, essentially it was a transformative journey for us, right? So we had to sort of figure out what are we going to do, right? Our employees, their health was absolutely prime thing, right? So we had a series of sort of executive leadership meetings where he says, what are we going to do, right? So to take our employees' things first, right, we said we are going to start working from home. And fortunately, we had invested in the right IT infrastructure. We have Microsoft Teams across the company, and we had embraced that journey about sort of 3 months prior to COVID. So the timing was just right. So we are able to take all our employees, starting with China and across the world, right? Literally in a matter of less than a week, we were able to motivate our people to work from home, and essentially just to, I mean, some short-term things like allowing people to take their large amounts or whatever home was okay. But the core of the work that we do involves research and development on software, and that work can actually be done from anywhere, right? That was a very, and as you can see, right, companies like Facebook and Google and so on, they are sort of allowing their employees to work from home. We, fortunately, the work that we do can be done from home, right? Except that our work needs high performance workstations, right? So what we did, the first thing was to enable our employees either to take their high performance workstations home or to essentially do sort of enable these virtual remote desktops and so on, right? So they can connect in from their home laptop, right? But to connect directly to their high performance workstation in their office and so on. So this is what employees' health was number one, but we immediately started working, right, where the people started working from home. And we were afraid that because this started happening in the first week of March, and our first release was scheduled for in 2 weeks, sort of 2 months from now. We did not miss a heartbeat, right? In terms of our productivity, we got our R1 release absolutely done on time, and the customer, our employee productivity actually did not suffer. So we were able to sort of work through the pandemic and the work from home and so on. And today, I mean, our R&D engineers are all working from home using Teams, and they're super, super productive. And our engagement with customers, I mean, in my role as CTO, I was engaging with customers every week, flying to different locations and so on. And the expectation was that customers wanted us to be there in person. And these days, the customers' expectations have also gone down, right? And therefore, they're completely okay with having remote meetings. I mean, just last week alone, I had sort of 6 very, very important customer meetings, right? With customers in Europe, right? In Germany, customers in Japan, ASIN, customers in Houston, customers in Milwaukee, and so on. This kind of productivity we could not do with customer meetings, right? In the past, because in the past, I would have to do these 6 separate travels, right? Once fly to Houston and back, then go to Milwaukee and back, then go to Germany and back. Now we are able to do all these meetings, right, remotely using Teams and WebEx and so on. So we have pivoted, but we have been quite successful.
So how is it in China now? Do you have people back in the office, or?
People are back in the office. So in China, things have actually returned to normal. I just spoke to the Chinese R&D leader, and yes, the China office has actually returned to normal. They're going to the offices and they're working with their customers as well.
Wow. And so what about you? Are you traveling?
I am not traveling. No, I have been working. This is sort of what I was saying. I'm actually working from home, but my personal productivity has gone up because in the past, I mean, half my job was to be in front of customers and to, as I said, right, to have a meeting with the CTO at Honeywell, right, who is based in Atlanta, right. I used to have to figure out fly to the previous day to Atlanta, then have a 2-3 hour meeting, then the next day fly back, right? So you lose sort of 3 days for a 2 or 3 hour meeting. Now you just schedule a 2 hour meeting right then in the middle of the week, and the following meeting can be with a customer in Japan, right? And this is how I've been super, super sort of productive. My productivity has actually gone up, and my travel has gone to 0.
That's great. And so in actually what people really might be interested in the midst of COVID, you actually, ANSYS closed their biggest deal ever.
Absolutely.
So can you tell us about it?
Yeah, so we had, again, not just one, we had several big deals, but we were able to scale, I mean, this was a long-term customer, right? We have had very strong relationships with this customer in the automotive industry, and this was the largest sort of, I mean, 8-figure deal. This is just, it's unbelievable how we were able to do this. And again, this is a customer who has been with ANSYS for the last, I would say, 20 years, and we have been working with them in this automotive industry, right? In terms of engine designs and so on and so forth, right? For like more than 20 years. We started with our mechanical product, then we added our fluids product, then we added our electromagnetics product, then we sort of partnered with them on their journey towards electrification and so on. So we have been with them for a long time, but there was time for a renewal, and we had a very, very impressive, important set of meetings where our CEO, our head of sales, myself, everybody was involved, and we literally closed that business. And it's a truly long-term partnership with them, where we are with them in sort of enabling them to really push to their journey of simulation-based product innovation in the presence of AI, machine learning, and digital twins and everything. So very, very exciting. But actually, that's not the only customer. We have had other customers who, I mean, like 3 or 4 really, really large deals that we are closing in this during the pandemic.
Wow. And so that's really exciting. And it's exciting because we're proud because of the history of ANSYS here in Pittsburgh. How many people are in Pittsburgh that actually work in the ANSYS headquarters in Pittsburgh?
So as I said, we have about 4,200 employees overall, and our Pittsburgh office has about, I would say, 1,500 in 2 large buildings.
Mm-hmm. Okay, great. And so let's talk about on a fun note. So ANSYS has been doing some great things in the autonomous vehicle industry. I mean, there actually isn't a company that is on the Fortune 500 or on the NASDAQ that you haven't touched. But, you know, you've been having some fun and in the electric vehicle, in the autonomous vehicle industry. Talk about your involvement in the industry and the engagement of the Indy 500.
Absolutely. So ANSYS as a company, right, we do simulation software, right? So the world around us is governed by physics, right? If it's a mechanical physics, it's governed by Euler's equations. If it's fluid physics, governed by Navier-Stokes equations. If it's electromagnetics, governed by Maxwell's equation, right? We take that fundamental physics, which is in sort of second order partial differential equations, and we convert that into numerical methods, and we solve it accurately. And when we say it is accurate, right? So in the past, you wanted to have a wind tunnel to test a wing shape and see and put wind at sort of 600 miles per hour to see if that wing will lift or not. These days, you don't need a wind tunnel. If we say through that sort of virtual wind tunnel test that this wing is going to fly, this plane is going to fly, right? So that's sort of how accurate our simulation models are. Now, so we have been working with different customers in different verticals. We have more than 45,000 customers in different verticals like automotive and aerospace and defense and manufacturing and high tech and so on, right? But we have recently sort of pivoted to solving some really large solutions, right? Which is, instead of picking a particular solver like mechanical or fluids, right? Let's try to take a collection of our products and solve a real problem for our customers, right? And so examples of such solutions are electrification, and we are working with Volkswagen on a fully electrification solution journey. We are working with Ericsson on a 5G complete solution for MIMO antennas and so on and so forth. We are working with companies like Flowserve and Kaiser on IoT. And then with autonomous, we are working with a large customer, BMW, right, in Germany, to completely solve their autonomous solution, right? And when you're looking at autonomous, right, what's the difference between an autonomous car and a normal car? In a normal car, you have a driver, a human, who is actually seeing the environment. He sees things, he hears things, and based on it, he kind of accelerates or decelerates. In an autonomous car, the eyes and ears are essentially replaced by sensors. You have LiDAR sensors, you have camera sensors, you have radar sensors, and we have the ability through very accurate simulation to simulate all those sensors and how, in the presence of fog or lightning or cloud or whatever, right, whether the camera will actually work or not, right, whether the LiDAR will actually see it or not, right, or in the presence of metal and so on, right, will my radar can do the right thing or not. So we have the full physics capability to look at all the sensors, but we can also simulate scenarios, right? So when a Waymo car, a Google car goes around and takes videos, right, 20-minute videos of when they're going on Golden Gate Bridge, I mean, in an actual road testing, you can see whether that car will brake or not in the presence of 3 pedestrians and when it's 9 o'clock sunny in San Francisco. But we, through simulation, can do a what-if analysis of what if it's instead of 9 a.m., it is 9 p.m. in San Francisco. And what if instead of sunny, it is actually raining and snowing. And instead of 3 pedestrians, you have 10 pedestrians and a dog and a cat. Can my car still work? So all those different scenarios, you have to wait for 10 billion miles for the car to be tested. And this is sort of what all the car companies are driving towards, right? So with road testing, you have to drive a car for 10 billion miles, and they have driven only 25 million miles so far. So with simulation, you can essentially do accelerated sort of simulation, the road testing, that virtual road testing for 10 billion miles. This is the power of autonomous solution that we are bringing to market with customers like BMW. Now, what we have done is to sort of do something exciting. We just partnered with the Indy 500, right, the Autonomous Challenge, and we have now partnered with more than 40 universities and say, next year, these students will have access to the same AV solution that we are partnering with the large companies, like the companies like BMW, they have this. We are providing the same software environment to these 40 sort of student groups, right? And they are essentially going to test out, right? And they'll have the same car chassis, the same sensors and so on, and the same autonomous software from ANSYS. And using this software, hardware software platform, these 40 sort of student groups, and they are truly international groups, they're going to run the Indy 500, right? And see which autonomous car drives the faster. It's a fun project, very exciting, very high visibility.
So when is this? When is this so that we can track that?
This is, oh God, I have to look at the date. I think it's in May of 2021, but I will just look it up and let you know.
Share it with us and we'll share it as well. We'd like to participate. And so these universities are from all over the world?
Exactly, they are.
Oh, that's really fun. That's really fun. And so everyone can tell how passionate he is about the work he's doing. So it's always thrilling to talk with you, Prith. So in addition to autonomy, though, ANSYS has also been studying the impact of electrification. And, you know, you released a study actually on the topic earlier this year. It would be great if you could talk about that survey or that study and, you know, tell us what you've learned.
Sure. So let's first talk about the electrification sort of journey, right? So the car that you and I drive today, or maybe last year, right, was driven by an internal combustion engine. It is a sort of gasoline-powered engine, and because of it, you had a certain powertrain and brake systems and so on, right? Now, and you have brakes and accelerator and so on in your normal internal combustion engine. The future is all about electrification, right? And so, okay, so I'm going to have electric car. So for that, I need electric motor. For electric motor, you need to have batteries that drive this thing, right? And you need those power electronics, right? The drives and so on to drive the electric motor from the energy from the battery. So essentially, we have at ANSYS the complete solution flow, right? To model batteries, to model the electric car, the electric motor from Maxwell, the battery modeling from Fluent, the power electronics from Simpler. So we have all those individual abilities, and that's sort of what we brought in our solution for electrification working with Volkswagen. So now okay, I just saw from Tom, he says that the final race is October of 2021. So I was wrong. I thought it was May, but it's October 2021. Thank you, Tom. Thank you, Tom. So we partner with Volkswagen on our electrification solution. And essentially there is this really cool race out there called Pikes Peak, right? Which is this very incredible thing that you have to climb up, right? And people actually try to go on top of that with sports cars with gasoline powered engines, right? And the speed limit was like in 10 minutes can you go up, right? So here's a driver that uses the fastest possible Porsche or whatever car to drive on Pikes Peak. Volkswagen wanted to do it with electric car, right? And the way the race worked is you could only do it once, right? So he couldn't do like 100 different tests and said, try it with this battery size, that battery size. It was only one shot. So it was the ultimate test of simulation-based product innovation, right? So we partnered with Volkswagen and said, okay, you can have a much larger motor. If you have a big motor, obviously you can go faster, right? But if you have a much larger motor, then you need a bigger battery. Then you have a bigger battery and a bigger motor, it makes your car heavier. Therefore, you need even bigger battery, right? So that it will go through. So we partnered with them on the full system simulation, right? To figure out the right size battery, right size electric motor, so it could go on top of Pikes Peak in under 10 minutes. And we allowed them to beat the Pikes Peak. So this was like an amazing feat for us and an amazing feat for simulation-based product innovation, right? So I'm super, super excited about it. Now, the survey that we talked about, right, was actually sponsored by ANSYS, right? So are you, right, as a customer, willing to embrace electrification, right? And are you willing to do this or not? So we have essentially said some surveys around, are you willing to take a electric car or an autonomous car and so on? And what we found, right, which is quite aligned with our thinking, right? Absolutely, people are willing to embrace electrification. People are willing to embrace autonomous and so on. And we did those surveys about sort of security, sort of safety and so on and so forth. So it was, I mean, the survey that we did was very well aligned with just what the business thinks. But I wanted to highlight with my sort of passion, right? How important, how exciting it is to come up with a full autonomous solution, right? Or a full electrification solution for our customers.
Yeah, that's amazing. That's so great. So what are you excited about as we enter these next 6 months, right? Because we're all over the world. There's been, various reactions in terms of COVID. In China, people are back to work, but in other places, they're back on lockdown. But in terms of ANSYS overall, what are you excited for? What do you think? What are your thoughts?
I am excited about, as CTO, my responsibility, Audrey, is to look at the long-term technology for ANSYS, right? And we have a bunch of solvers, like our mechanical solver, electrical solver, fluid solver, and so on, right? And so when we solve our problems for our customers, it's about running it faster, running it in a more stable way, and ease of use and so on, right? So I am sort of looking at it from a technology perspective. How can our simulation software be better for our customers? And there are about 8 pillars that we are looking at. And one of the pillars is AI and machine learning, right? Again, being in Pittsburgh, right? I mean, it's sort of the hotbed of AI, right? I mean, right next to Carnegie Mellon and so. Right. So, but AI ML has been used in a lot of other disciplines, right? I mean, from natural language understanding to speech and all kinds of stuff, and EV car and so on. So what we are looking at ANSYS is, can AI machine learning accelerate simulation, right? And so we had a little sort of a theory, right? 2 years ago when I joined, I say, hey, can I use neural networks to speed simulation up? And we had some early thoughts. Hey, let's try to take a neural network and run a sort of electromagnetic simulation on some simple primitives and train that neural network and train it. And what we found, through data-driven neural networks, it can actually speed things up. Then we came up with this technology of physics-informed neural networks, and that speeds up even more. So we are at ANSYS looking at the use of AI ML to really accelerate the use of simulation, right? Accelerate simulation by a factor of 100 to 1,000, right? Super, super exciting technology. Is it in today's products? No, it will be in future products, right? So that's one thing that I'm very excited about. Second thing is the whole area of hyperscale simulation. Very, very sort of, how do you take, all the stuff that has happened in the parallel processing community, right? With shared memory, multiprocessor, message passing, and so on. Stuff that our university colleagues at University of Pittsburgh and Carnegie Mellon and all the other universities are doing, right? So we are exploring all forms of parallelism using shared memory, GPUs, the GPUs from NVIDIA and AMD and all right. And so we have looked at single GPUs or multiple GPUs. The future supercomputers will have multiple GPUs per node, multiple cores per node. So how do you take our solvers and scale them up with what I call hyperscale performance, right, on these future machines? That's another thing. We are looking at multi-physics simulations, whole area of platforms. We are looking at digital transformation. We are looking at IoT and augmented reality, virtual reality, transitioning things to the cloud, HPC on the cloud. So there's a lot of stuff that I'm excited about.
What about in healthcare? Anything in healthcare?
That's a fantastic question. Absolutely. So we have been in different verticals, right? Our strong verticals has been automotive and aerospace defense and manufacturing and so on, right? There's one vertical that we had not paid attention to in the past was healthcare. But if you look at the amount of R&D investment in healthcare is about $240 billion, right? In every industry, if you have a lot of R&D investment, there is a sort of about 2 to 3% of that investment is in simulation. So we identified, right? If R&D investment is 240 billion, that's a lot of sort of opportunity for simulation based product innovation in this area. So in the CT office, I am actually personally um, looking at, right, healthcare, sort of simulation is healthcare, and the particular problem we are looking at is simulation of the heart, right? The heart is this most amazing device, right? When you look at the heart, right, you look at the aorta and the ventricles and so on, there's a mechanical part, the muscles that are going on the heart. Then the actual signals, right, the 72 heartbeats that you have per minute, right, there are electric signals that are going. So you have to model those electric things through electromagnetics or HFSS. You have to model those mechanical stuff, right, the muscles through this. And because of the muscles, you are actually doing blood flow from the ventricle to the arteries and veins and so on. That is all modeled through the fluids truth. So we have this software called LS Dyna, which is doing simultaneously fluid structure and electromagnetic simulation. And we are working with the likes of Medtronic, right, to do medical device things, right? When you're inserting a pacemaker inside a heart, right, to treat your arrhythmia and so on, right, that requires full heart simulation. And those are the kinds of exciting things that we are working on today.
Wow. So what about hiring? What about hiring in the Pittsburgh region? What about, what's happening there?
We are doing a lot of hiring. In fact, the interesting thing, Audrey, is that our hiring has not stopped at all, right? I mean, we had plans to grow our company, right, in R&D, in ACE, our sales organizations and sales support and so on. And we have done whatever plans we had to support our customers, we have done that. And again, a lot of the hiring has happened in Pittsburgh, but these people who came on board have essentially come on board and they're working from their apartments or homes in Pittsburgh. But we are a global company, and these people who are working from their Pittsburgh homes are sort of supporting R&D across as well as customers around the world.
Is there anything else before we wrap up? First of all, thank you for your passion. Thank you we're thrilled that ANSYS is in our region, and just your energy and your experience across almost every vertical is pretty amazing that we've tried to pack in these 30 minutes. Is there anything else that you think our audience really needs to know that perhaps we didn't discuss?
Yes, one thing that I wanted the audience to know is that sort of in the computing area, cloud is coming, right? So instead of having all your software or whatever running on your workstation or on a sort of a cluster computer inside a customer site, right? People are kind of thinking of moving to the cloud. So we have a big initiative in the cloud at ANSYS, but because of the pandemic, right, what has happened is the acceleration to the cloud has really, I would say, has accelerated. I mean, the movement to the cloud has accelerated because people, our customers, are sitting in their own office or whatever, right, working on, say, low performance laptop or whatever, right, and they want to do very, very accurate, say, fluid simulation, right, for an airplane, right, of a virtual wind tunnel, right? You cannot do that on your workstation. Therefore, you have to go to the cloud. So we are enabling our customers to take all their simulation to the cloud in all verticals. That move, just like online retail, the move to Amazon has been accelerated by COVID. The move towards simulation-based product innovation, right, where you don't actually have to test your thing in a hardware lab, and doing that simulation on the cloud, that journey people were already on, but it has been accelerated because of pandemic.
Great. So you have a couple of people just to say out loud is just to give, shout out from Ray Huber at Eaton. ANSYS provides all of our simulation software. Love it. You have Rebecca Mink, who's talking about ANSYS about Alcoa in the 90s. Many of the projects was the all aluminum Audi. Had a great time using your software. Thanks for the insight. Steiner's talking about continues to be one of the most impressive global companies which works in Pittsburgh. Bravo. I mean, thank you, Prith. So someone saying what has been one of the most helpful resources in your planning of all these items, that might be directed towards Brian. But I think that what you hear is just a lot of appreciation for what emanates out of here, and we're staying close to you. First of all, Prith is on the board of directors of the Tech Council, so I wanted to share that. He is accessible, he cares, and you can hear from everything that he's articulated that he's passionate, he's wicked smart, he has a great sense of humor, and he's driven. So they're lucky to have someone who comes from academia as well as from startup world to bring that to this world. So really, really appreciate the time with you, Prith. I do want to thank everyone for being here today. And I want to tell them that we also have a couple of things in store this week. Every single day we're doing something. But we've just gotten verification that we will have Paul Mango, who is at the U.S. Department of Health and Human Services, and he runs Project Warp Speed. We also are going to be talking to a major power developer. We have the CEO of Oriton, and about Project Warp Speed. It's just a partnership designed to bring the vaccine to market. So we're covering every topic. And we're pretty thrilled about bringing all this to you. So you can find Prith, I think, on LinkedIn. You can see all the work that he's doing. I think he also writes a little bit in some blogs. And he is just someone that we're really thrilled to know. So thanks, everyone, for joining in. And we'll see you here tomorrow. Thanks, Prith.
Thank you. Thank you. Bye-bye.